In Lesson 11.2, we're going to be learning about how to conduct a chi-square goodness of fit test. Our book refers to this as a multinomial experiment. And so I want to show you how you can go about conducting this test using Minitab. It's really quite simple. So here's an exercise in one of our web assignments that says, a manufacturer of floor polish conducted a consumer preference experiment to determine which of 5 different floor polishes was the most appealing in appearance. A sample of 100 consumers viewed 5 patches of flooring that had each received one of the 5 polishes. Each consumer indicated the patch he or she preferred. The lighting and background were approximately the same for all patches. The results are given below. Solve the following using the p-value approach and solve using the classical approach. So you can see the 5 polishes are labeled A through E, and you can see the observed frequencies. And in part A, it just asks you to state your hypothesis for no preference in statistical terminology. So we haven't been given specific proportions, but just we believe that the proportions are the same and want to see if we have evidence to say that they're actually different. So this is one where all of the proportions are the same. And in the null hypothesis, therefore, since there are 5 proportions or 5 categories, the null hypothesis would say that all of those proportions are equal to 1/5 or 0.2. So that's why the third option is our correct choice there in part A. In part B, we're asked to identify the test statistic that we would use in determining this null hypothesis. Well, when you've got more than 2 proportions, you've got to use a chi-square test. And since there's just the category of polish, not a second category, we'll learn about those tests in lesson 11.3, then this is a goodness of fit test. But our choice is obviously the second one there, chi-square test. In C, complete the hypothesis test using a level of significance alpha equal to 0.10. First, find the test statistic. So I logged into my Minitab account and I entered my observed counts given in the problem in column C1. And then because there were 100 pieces of data or observations, and we expect 1/5 in each of those categories, 1/5 of 100 is 20. So I entered my expected count of 20 for each of the 5 categories. Now to compute the test statistic, I just need to go to Stat, Tables, and you see one of your options here is the chi-square goodness of fit test. We have one variable, and that is the polish. Now, as always, you have to click in the box first. If I want to bring my observed counts over, I have to click in this box, and my observed counts I put in C1. So I'm going to double click on C1. Then down here in the test menu, you see you have the option to choose equal proportions, specific proportions, or proportions specified by historical counts. So I really didn't even have to put those expected counts in C2. In this case, we expected them to be equal, so I chose equal proportions. And then you click OK. That gives you a number of different graphs. Here it's just showing you the distribution of the observed counts, and clearly we saw that polish number 3 had the most, and so on. And here is a comparison of the observed and the expected. I find this graph to be a bit more valuable because I can see, for instance, that for polish number 4, we observed the same number that we expected, whereas in polish number 1 and polish number 5, we see that the observed counts were greater than the expected because the blue bar is higher than the orange bar. And in polish number 2 and 3, we see that the expected were greater than the observed. So that's an interesting graph to take a look at. But what I'm really interested here in is my chi-square test statistic and my p-value. So this table gives us that comparison. It shows us what we observed in polish number 1, what we expected for polish number 1, and what the observed minus expected quantity squared divided by expected turned out to be for that polish, 1.25. And then it shows the same information for all 5 polishes. But if I scroll down, here I have the results of my chi-square test. First, it's telling me that the number of observations that I had was 100. The degrees of freedom for goodness of fit is always the number of categories minus 1. So we had 5 polishes, and 5 minus 1 is 4. The chi-square test statistic is this value here. Now in this particular problem, it's asking us to round that to 2 places after the decimal point. So on a PC, all I have to do is right-click there and go to decimal places, and I'm going to choose 2. And I see that that rounds to 5.10. And then the last column here is the p-value. And obviously that's quite a large p-value, much greater than the level of significance given. So we're going to fail to reject. But in this particular problem, it's wanting me to give my p-value rounded to 4 digits after the decimal point. So I'll right-click here, choose decimal places, and then move this down to 4. And I can see my p-value is 0.2772. So you can see that the chi-square test statistic that I obtained using Minitab is the same as the reported answer here in our web assignment. And you can see that the p-value of 0.2772 is also the same as Minitab reported. And of course, when p is not low, we do not reject the HO, and therefore this is our option in terms of our conclusion.